Hello guys, welcome back to IICS Infotech channel. So today we're going to discuss about SQL transformation. Before that, I just want to request you all, if you see my YouTube analytics, so there are a lot of people, they are not subscribed to my channels and most of them are watching all my videos, but they are not yet to subscribe to my channels. Guys, I know you people are like my videos, so that's why I can see here overall 77% people are watching my videos and they are not subscribed. So I can see only subscribed is 22% out of 100. So 77% people are like my videos and they are showing interest whatever the videos which I have created and what are the scenarios which I have explaining here. So this alone itself it can explain. So out of 177% people are liking my videos. So I request you all to subscribe to my channel so that it will motivates me to do more scenario based videos so that it will help a lot of people who are looking for IICS jobs. Okay. So I hope you guys understand my situation. So please support me. Okay. Now let's dive into today's topic. Okay. So SQL is nothing but structured query language, right? So in IICS, so if you want to execute some SQL statements in between the mappings, okay. So if you are end up with such kind of scenarios, we can use this SQL transformation. Even in Power Center as well, we have this SQL transformation. Okay. Let's understand this SQL transformation in detail. See, as I mentioned here, SQL transformations are used within data integration process to transform and manipulate data directly in the SQL database. So from IICS, we can directly execute our queries in databases. Okay, so that it will reduce the need of extensive data processing in the cloud environment. So this is especially useful for improving performance when working with large data sets. Okay. So this SQL transformations, it will allow us to write a custom SQL queries to perform any kind of operation such as if you want to filter out some data before loading into the target tables. So we can use this SQL transformation and we can write some filtering queries, or if you want to join some conditions, okay, if you want to join some data, so we can use this write this joining query in SQL transformation. Or if you want to aggregate some data and load into the target table, okay, so we can use this SQL transformation. And there are some aspects, key aspects. I have given some use cases and what are the benefits if we use this SQL transformation and what are the features we have in SQL transformation. So use cases here we discussed filtering, joining and aggregating. So those only I have mentioned here. You can just go through this document so that you will get a clear understanding. Okay. And what is the performance benefits? If we use this SQL transformation, what are the benefits we will get and whether we can improve the performance of the jobs or not. Okay. So it allows processing to occur directly within the source database or a staging database. So if you have a staging database, if you do any some kind of uh, operations in the SQL transformation, so it will directly run on the staging databases. Okay. So this the processing power of the database engine. This minimizes the need for resource data manipulation in the cloud environment. So by pushing computations to the database layer, it reduces network load and data movement. So if it reduces these things, then obviously it will improve overall job performance. And let's see what are the features we have. So we can write, select, insert, update, delete, or we can write some custom SQL statements. Okay. So that will be depending on the business logic. and we can write pre or post SQL commands. And moreover, this SQL transformation, it will support stored procedures, stored functions, and SQL query as well. Okay. So we have some advanced use cases where we can generate dynamic SQL queries during runtime. Okay, based on input parameters or session variables. Let's see one use case here. Suppose you are working with a large dataset stored in a relational database, either it is SQL Server or Oracle, and need to filter rows, and you need to perform a join between multiple tables. And at the end, we need to calculate some aggregates such as totals or total averages. So there is a example here. So I have written some query. If you have some data set, okay, so that if you want to do some aggregate calculations like some count, okay, based on the order date, so you can try with this query. Or we have another use case here, and there are some configurations and connection types that we will discuss practically. Okay, and what are the limitations we have if we use this SQL transformation? So for complexity and portability and database dependency, okay, for extreme complex transformations, mappings, and debugging, custom SQL queries can be challenging. So because this needs to be run on the direct databases, right? So if we have any complex transformations, it might difficult to debug the queries. So that's about complexity and portability. If you see portability, SQL syntax can vary across different database systems, right? And which may create portability issues if moving between different platforms. Yes. Let's say now, as you can see, Oracle versions has been changing, right, from one version to different versions. So there might be dependencies will be there, like if suppose Oracle 18, it was released Oracle 11, it was really long back, right? At that time we might having some Linux old versions. So in that way, each systems and each databases will be migrate. The versions will be changing, right? So at that time, portable issues also we will be seeing, right? So that is all about here. So that's all about database dependencies and portabilities. Okay. So here also there are some best practices out there. SQL queries are optimized for performance and especially when working with large databases and minimizing data movements. So this has to be taken care of. If you are moving data from one moving data sets from one transformation to other transformations. So filter and process as much data as possible within the database to minimize the volume of data moved through the cloud pipeline. So we can use parameterized queries as well. So whenever possible, we can parameterize queries to make SQL transformations more flexible and reusable. So this is all about this SQL transformations. Now let's see one practical use case. So I have one use case here. So to find total revenue, total cost, and total profit. So these are the formulas to find out total revenue. So unit price into units sold. So we will get total revenue and total cost, unit cost into units sold. And to get total profit, so we need to do total revenue minus total cost. Okay, I have a data set, sales data. So I have a, in the source I have sales data. Okay, so in target, so I need to uh, get, if you run this query, this is the target table. So I need to pull the data from source and I need to calculate the total revenue. So I need to calculate total revenue and load into the target table. Okay. So we can use this store procedure. We have to create one stored procedure on total revenue. So this is the query to create total revenue stored procedure. So okay, how I am creating here is, so this is stored procedure name. So here I am taking transaction ID, okay, in transaction ID, and out is O underscore revenue. So total revenue, it's a number or decimal, it's a 10 comma 2, and here select unit price into unit sold. So I am uh, pushing this value into the, I'm storing this value, the result value into total revenue, okay, from the transactions table. Here is okay, sales data. So where the transaction ID equal to transaction ID, okay, and the total out here, the total revenue whatever I'll get, I'll be storing into this O underscore revenue. So here I have created the same store procedure. If you click on this, sorry, procedure. So here I have total revenue, total cost, and total profit. This is total revenue. Now we're gonna work on this. So I have a transaction table. From transaction table, I'll be getting this total revenue. Okay. So now I'll just rename it as a sales data. Okay. From sales data, I need to load into target sales data with the total revenue. So this is source and target. Now let's move on to the IICS, how we can practically implement this. Log on to IICS and let's create a mapping for this. So I'm creating mapping. So I'll name it as M underscore SQL transformation. Okay. So click on source. Let's quickly configure all these source and target. Source is a source. So let me select sales data. Click on OK. So these are the fields which are coming from the source, right? Now let's select target. So target is in target schema. Select the target table. So this is the target table, and it's a insert, and I'll just enable the target truncated table. So these are the fields. So we have a total revenue. Now we need to get the total revenue by using SQL transformation. Okay. So select the SQL transformation. Let me save it first. So click on this SQL transformation, and we have a, here you can see, click on this SQL. Now what we are doing is, it's a connected one. So we have a like lookup, we have unconnected and connected lookup, right? In the same way, we have SQL, connected SQL and unconnected SQL. Okay. I mean store procedure. Okay. Unconnected store procedure and connected store procedure. So let's connect to the source, and we need to select the store procedure. If you have the store procedures in your source schema, it will automatically fetch. So these are the store procedures I have created. Now we are dealing with the revenue, right? So let me select that total revenue. So if you want to work as unconnected store procedure, then you can opt for this. Okay. So this is the store procedure. Now as you can see, I have a transaction ID in and field mapping. Here we have a in trans ID, right? So we need to connect with trans ID. It's like a in lookup we will give condition, right? So if this matches, then only it will do the calculations. Then output field, this is the output for revenue. So now go to target, we need to map, right? So field mapping. So here we have only one, okay, but we should get all the rest of the columns, right? So for that, what we need to do, just connect from source to target, so we will get all the columns. If you go to field mapping now we'll see all the columns. Let's do smart map. So if you see here, we map output of revenue to the which will come from the SQL transformation. Okay, now this we are mapping it to the total revenue in our target table. So click on this. Let's save the mapping. So create a mapping task and run the mapping. Okay. So let me run the mapping now. Go to my jobs. So we got 101 records. Let us check in the target table. Okay. So we don't have any data. Now let us run the query. So as you can see here, so we got the total revenue. This is how we will use the store procedure. Okay. So I hope you guys understood this. And what you can do, so I'll give the sale data. Okay. So what you can do is you can try to find out total cost and total profit. Just take the same store procedure query. Here instead of total revenue is there, right? Just replace with cost and profit and create two more store procedures and create two more mappings. Okay, however I have created like this, you just create in the same way and check the data in your target table whether you are getting the expected. If you want to do some to find out this is whether this total revenue is correct or not, you can just uh, take this formula. So you just multiply unit price into units sold. So unit price and units sold, just multiply with this. Okay, and you will get, if you get the same matching number, then whatever the store procedure we have created, it is working fine. Okay, so this is all about store procedure. So let me know in the comment section if you are facing any issues on this to finding out total cost and total profit. Okay guys, uh, I'll be giving this document link, okay, and as well as the sales data so that you can practice this one. Okay guys, this is all about SQL transformation. And just a small request, please do subscribe to my channel. Okay, thank you for watching my videos. Please do like and comment in the comment section. We'll meet in the next session guys. Thank you, have a great day, bye.